And here is the final story for today. And this is the story how exactly we can analyze all this text that we've been collecting for such a long period from all types of social media, from YouTube, from Twitter, from Facebook. How can we analyze these texts? And here I would say are four great texts, not to analyze, but to read. First of all, to read about before you start trying to do this. So the first text is a chapter 6 from Digital Social Research book. You might be already familiar with. After you checked it, it's very simple, good language, easy. You move to one of the foundational texts in this area. And obviously, all those texts, as I mentioned, they refer to politics, to political science, to political communication, just because I provide them with you because I provide you with them because that's what I also focus on in my work. So I know something about this area. Text as data, the promise and pitfalls of automatic content analysis methods for political texts. Great text, check it, and you will see the overview of all types of approaches to analyze text using algorithms and computers. A scaling model for estimating time series party portions from text, difficult title, but important if you're interested in one of the key approaches to analyzing text with supervised learning methods. And final text in this bunch of, I think, very important foundational text, if you're interested to learn about text analysis, is about unsupervised learning. What is supervised, unsupervised learning? I will show you in a second. And here is this famous branch tree from the article I already mentioned to me, text as data. See, it shows the process of text analysis, process of choices you need to make in order to understand what type of approach to text analysis to take. So the number of approaches you can take, but in any case, as you remember from the first slides, in any case, when we approach data, we start with trying to collect it and trying to understand what type of questions we can ask about data. So just like in the previous steps, we start with analyzing how to get data and what type of questions we can ask about it. Once we have an answer to this question, and once we collected data and cleaned it, and this is another big process, of course, we got a few options. One option is to look at what, especially they like it in America and American political science, look at ideologies of people who discuss politics, for instance. And this is a separate approach. I'm not sure I will be talking about it right now because it's very kind of specific type of problem. But another approach is more general and can be applied to any type of text. We are interested in ideology or not, and this is approaches that here described under the label of classification. So the key task essentially of any text analysis is to classify text, to map it out, to understand what's going on in this text. And of course, there is a method for this, method that you might learn very well, know very well. And this method allows humans, without any computers, to analyze text systematically, to classify it. Pause the video and think, what is this method? What is the name for it? And definitely you know it from your methods classes. And this is, of course, what? This is, of course, content analysis. So content analysis is this method that everyone uses if they want to classify text systematically. But it's also, there is one disadvantage to this method. It is that we sometimes don't have enough time to analyze text. Imagine that we have those 1 million videos, right? Can we check 1 million posts rather with links to video, like in YouTube example? Can we check every post from this 1 million list? Not really. Yeah, it would take a lot of time of many people. And if you take invite many people for content analysis procedure. You need to kind of synchronize the activity. You need to explain them how to do so they do it in a similar manner. Not easy, right? That's where computers help. That's where those algorithms developed for automated text analysis using data methods come in. And there are two main approaches to classification of text, of learning what is inside. One is known as supervised, and another one is unsupervised techniques. So the first approach is an approach we take when we know categories that are inside the text. How do we learn about them? How do we know them? That's where humans help, real humans. So we ask researchers, we ask people, we ask students to classify a little bit of our sample. So we take 10%, for instance, of tweets on a specific topic, for instance, about COVID-19. And we ask, if we collected, say, 10,000 tweets, we ask 2 humans to analyze 1,000 of them. And that's when they come up with some idea what might be inside. What is the most popular discussion in those tweets? What is the most popular suggestion about COVID people express? That's when we get categories. Next step is to understand what do we want from those categories. Do we want to know, for instance, sentiment of those tweets? In other words, emotions of those people who wrote those tweets when they've been writing, or we want to know something more substantial. So dictionary methods very often refers to analysis of texts based on some dictionary already available that defines essentially every word and gives them some specific additional classification. And that's why, since method is often used to understand emotions of text, understand emotions of people who write those texts, sentiment analysis is one of the key examples of using dictionary approaches. But now we move on and actually try to think in broader terms again. We can learn not just emotion, we can learn what people think about COVID-19, right? When they discuss it on Twitter. We can think what worries them, what they think of politicians who manage the crisis. And that's what supervised methods can give us. Essentially, supervised methods take those sample we looked at with humans and try to extrapolate classification emerged from the sample to the wider text, bunch of tweets we're looking at, which is called corpus. So we essentially use statistical methods to expand our classification based on probability that specific category within our analyzed sample can appear that many times in not analyzed parts of sample. There are many approaches here. You can learn about them. README, for instance, is one of the algorithms often used. Check them. Check text as data article and see if you're interested in one of those approaches. Choosing an approach really depends on the circumstances and context. And second road you can take when you approach this, if you're interested in the classification of text, is unsupervised methods. This one involves even less of human and even more of a computer. So here, you don't really ask anyone to classify text beforehand. You just take text and give it to a computer, and then you need to make certain assumptions, or computer helps you to make certain assumptions to understand what are the topics, key topics that emerge from the text, what are the key ideas sometimes that emerge from the text. There are several approaches, as you see, there are quite many of them. I will give you an example of this one, something called LDA. But before that, I will present you with few important principles to think about when it comes to text analysis. And here, there are 3 principles to think about. Principle number 1 suggests that all quantitative models of language are wrong, but some are useful. How do we understand that? Here, I think it means that whatever algorithm we use, it would never be as good as a human, a linguist. But even the most sophisticated linguist sometimes cannot uh, perfectly analyze text, which means that um, sometimes it's important to understand that text analysis is a complex procedure, and algorithms would never be as good as humans, but still they can be useful. And that's why quantitative methods are helpful, but they don't replace humans. Final principle suggests that there is no globally best method for automated text analysis. They're different. There's still a lot of research going on about which is the best way to use when it comes to text analysis. And obviously it depends on circumstances, depends on situation. But there are some kind of indeed global approaches that comes from linguistics mostly. One of the approaches that's very often taken in those text analysis approaches is it involves tokenization. So the process of breaking up a stream of text or a character sequence or a defined document unit into phrases, words, symbols. Here's an example. See, there is this example of bag of words. And essentially what this concept suggests is that, you see, those words are not in any sequence. So very often we break sentences into separate words, and we don't care about sequence anymore. We care about words, just how many times single words appears in text we analyze. Then we often look not just for words, not for any word, but for lemmas. Yes. So basic. It's a basic form of word. So you see, there is word weapons, and this is not really the basic word form. What will be basic? If we remove plural, we would get the basic form of this word, and so on. Very often, we also try to get rid of words that don't contain any meaning, like not, but, and. These are not very useful for us. What's useful? This one. This one. This can give us some meaning, right? It can give us some idea what text is about. Finally, we distinguish units and corpus. Corpus is the whole set of text we're analyzing. Units are specific bits we're mostly interested in, and normally they're words. Yeah, that's what is it about. Key principles, text analysis with algorithms. Finally, let's look at specific approaches. So I mentioned there are two main different approaches to text analysis. One is supervised and another one is unsupervised. Let's look at the example of supervised learning methods. They often contain three steps. The first step is training set, and that's what we call that sample that is analyzed by humans. The second step is applying the supervised learning methods, there are many, to learn the relationship between features and categories in the training set that use and then use these to estimate the labels in the test set. So again, we apply algorithms from sample we analyzed with humans, and then try to estimate based on them what's going on in a bigger text, in a wider set of units we're interested. And finally, we validate our model. And that's essentially looking at how successful it is compared to how successful it is in estimating what's going in bigger text. And for that, we can compare, for instance, results for the training set with the results of analysis for the test set. Validation is a key instrument that helps us to choose a right method of text analysis, as there are many. An example includes individual methods. In that approach, the training set is used to learn about distribution of words for documents from any specific category. And this distribution is then used to classify each of the documents in the test set. The distribution is a statistical concept and it points out towards presence of some specific approach from statistics to analysis of texts, right? That was supervised methods. Unsupervised methods, as I mentioned, like LDA depicted on this slide, does not involve any test training set. So no humans here. We just give text to a computer and give computer certain estimations based on our knowledge about possible text, possible expectations about text, and computer tries to come up with several topics. That's what topic modeling is about, right? One of the key questions is how many topics do we expect to find in the text? How extensive they are. For instance, from this text called Economic Rationality, we asked computer to find 3 topics, and it used its algorithm to find 3 topics. One of them is about firm, markets, business, economy. Second is about behavior, rationality, third about environment, adaptation. And see, then human work would be try to give a name, define what each topic is about, right? The first topic is what about economy and business looks like. And then we can build and visualize text based on which sort of which topic dominates the specific text. Here's an example from our work. As I mentioned, we've been analyzing 7 different platforms to get data from them about COVID and possible COVID misinformation. We looked at specific sources, mainstream media, junk news, as well as foreign state-backed media. And we looked at what the topics that dominated their coverage of COVID every week. And this is one of the last week's coverage. You see, this is the description. Quantitative analysis uses the articles with the greatest overall engagement in addition to articles that fit best into each designated topic or best fitting articles. What does it say? It says that we used topic modeling approaches, so unsupervised learning, to identify topics of most engaged articles from our set about COVID-19 from different platforms. So what people shared on those platforms, right? What people mostly engaged with, which articles get largest audiences. We identified it, and they try and asked algorithm to give us topics of those articles. And you see what we found, for instance, for this week, we found 4 interesting and dominating topics of many articles we analyzed. One was about presidential election in the US. Another one was about vaccine. And this one, of course, how we analyzed it. We looked at different keywords like COVID-19, health, people. We found that those articles contain quite a lot of those keywords, and vaccine as well, not on this slide, unfortunately, but there was keyword vaccine. And that would give us an idea that those articles might be about vaccine candidates. Fraud in the US election. You heard this story that President Trump claimed that presidential election in the US was essentially unfair and his victory had been stolen from him. And there were many articles that discussed this topic. And we found that most popular word was election in those articles: Georgia, president, Republican, state, fraud. And this is the key word here, fraud. You see, fraud is this word that points towards presence of this topic. In other words, first we identify a bunch of words here that dominates a specific set of articles, and they try to understand what is common among those words, what unites all those articles. And in that case, in the case of fraud in the US election, fraud is a keyword, right? When it comes to photos, it's kind of interesting story. Attacks on upcoming Biden presidency, it's politics here. So again, Biden, it's about Biden. And what it's about? It's about people. It's about Republican, but it's not that easy sometimes. So you see, it's not that easy sometimes to understand what's going on with topic modeling. What is the topic really? We need to read a few articles to get an idea, but it kind of makes our process of classifying text a bit easier. Here, a challenge here is to understand very often in topic modeling, understand what is the advantage, what is the outcome of our analysis. It's not always clear what really topic modeling tells us, unfortunately, interestingly. But overall, more and more people use it in marketing, in all types of industries. And obviously here, learning a few programming languages such as R or Python, key languages used in this area. R is more often used in academic research, Python more often used in industry. Learning them is always useful, and including useful for this type of analysis. All right, with that, I should conclude and thank you for your attention. Just to summarize, to remind you, if you're interested in working with big data, with social media data, it's important always remember a few principles of analysis. And it's important to remember that rigorous approach to studying data includes thinking and approaching as many sources as possible, but understanding which sources are of high quality, and also using basic statistical models and techniques to analyze data. That's what bring you, I believe, success and give you a lot of, provide you with many opportunities to learn about our world and society. Thank you for your attention, and see you. Bye.